Hello, Algebra 1 students, and welcome to the start of Topic 6, covering exponents and exponential functions. We are switching gears here and focusing on exponents. All right, so you should have done some of this in your previous math courses, but we'll try to give you some refreshers as we go through. So the big thing is exponents, yes? Okay. So when you have an expression of all the exponents, it looks like this: x to the nth power, right? So this big X is called the base, and this small n up top is called the exponent, or the power. Exponent. Can't spell. Exponent. Okay. And again, we're going to talk about rational today. So if you remember from our topic 1 discussion, when you hear the word rational, you should think of fraction, right? Because a rational number is a number that can be written as a fraction of integers. All right, so that's what we're talking about. But this is the big idea, right? Do you remember that the bottom number is called the base and the top small number is called the exponents? All right, so example 1, write radicals using rational exponents. So what does 3 to the 1/2 power mean, right? Well, down here we're going to do some investigative work. So let's talk about just exponents in general, right? So let's do 3 squared. So 3 squared is 3 times 3. It's 3 written twice, okay? 3 cubed is 3 times 3 times 3. 3 written 3 times, okay? So to try to explain what 3 to the 1/2 equals, I want to multiply 3 to the 1/2 times itself, okay? Well, there's this rule in exponents that if you multiply like bases, you add their exponents. So think about over here, right? 3 to the first plus 3 to the first, 1 plus 1 equals 2. Right? Same thing here. 3 to the first, 3 to the first, 3 to the first, 1 plus 1 equals 3. That's how you get your exponents. Well, here, if we add 1/2 and 1/2, you get 3 to the 2/2. And 3 to the 2 over 2, 2 over 2 is just 1. That's just equal to 3. Right? So what this means is 3 to the 1/2 squared, right? Which is 3 to the 1/2 times 3 to the 1/2, right? That is going to equal, well, there's another rule that says if you have a power to a power, you multiply the exponents. 1/2 times 2. If you multiply 1/2 by 2, this is just 2 over 1. So you multiply the top numbers. You'll get 3 to the 1 times 2 is 2. 2 times 1 is 2. You'll get 3 to the 2 over 2, which is, again, 3 to the first power. So all of this is leading to the following, right? If you have 3 to the 1/2, how does it compare to the number 3? Well, 3 to the 1/2 is going to equal the square root of 3. How do we know that? Well, again, this is a little bit further than maybe what you might know already, but if you have 3 to the 1/2 and you square it, and that equals 3, which is what this equation showed us, right? That just showed us this. Then if you want to get rid of the squared, you take the square root. And again, I don't know if we've covered this yet. I don't think we have. We'll do it later. But what you get here is the squared and the square root will cancel, and you'll get 3 to the 1/2, and that's going to equal the square root of 3. And there you go. So that's where that comes from. Okay. Another thing I can show you is the following. So if I take the square root of 3 and I square it, that would be the square root of 3 times the square root of 3. There's a rule in exponents, or rules with radicals, that you can multiply what's inside. So 3 times 3 is 9. And the square root of 9 is 3, if you look at a calculator. So if you take the square root of 3 and you square it, it equals 3. So if you take both sides, okay, watch the following. If you take both sides and raise it to the 1/2 power, which you're allowed to do, you can take both sides and raise it at the same exponent. Over here, you'll get the square root of 3. Multiply these. 2 times 1/2. We've done this. Is 2 over 2. And over here, you get 3 to the 1/2. And 2 over 2 is 1. Square root of 3 equals 3 to the 1/2. And there you go. There's another instance of why 3 to the 1/2 is the square root of 3. For square roots, right, there typically or sometimes with other roots, there's a number right here, it's small, called the index. But for square roots, it's not written, right? It's a 2, but it's assumed there, so it's just not written. Okay? So up here, this is kind of the summary. So if you have a number raised to the 1/nth power, it's going to be the nth root. Okay? So again, that's why I talk about the index. So 3 to the 1/2 is the square root, right? I don't think we're going to get this far. We might, but if you have a fraction exponent and there's two numbers, a numerator and denominator, the numerator is the power inside and the denominator is the index on the outside. Okay, so I know this is a lot. I feel like it's a lot telling you. So again, we'll do some problems and hopefully it helps you out. Okay. But again, if you remember nothing else from this slide, it's right here. That 3 to the 1/2 equals the square root of 3, and you'll be in business. All right, so let's take a look at this question. So it says, what is the solution to this equation? Okay, so right here, you have 3 to the x over 2 times 3 to the x over 3 equals 3 to the 9th. Notice here you have two like bases, 3 and 3 being multiplied. There is a rule that if you multiply like bases, you add the exponents. So right here, I'm going to rewrite this as 3, and I'm going to add the exponents to the x over 2 plus x over 3 power. Right? So that's one exponential expression, base, and a sum in the powers. And that's going to equal 3 to the 9th. Well, now, in this problem, since the bases are both 3, and there's one on the left side and one on the right side, you can get rid of the bases. So there's a rule, since the bases are equal, and again, it's because they're 3's, focus on exponents. So I'm going to bring this over here in blue. So if I focus on the exponents only, get rid of the 3's, right? Get rid of the 3's. So now it's going to say, we're going to make these exponents big now. X over 2 plus x over 3 equals 9. And now we need to solve this, right? I think I taught you guys how to get rid of fractions by using a least common denominator. So in this problem, there are two denominators, 2 and 3. You cannot make one become the other. So we're going to multiply by 2 times 3, which is 6. We're going to multiply everything in this equation by 6. So that'll be 6x over 2 plus 6x over 3 equals 54. Now, these will simplify. 6 divided by 2 is 3x. 6 divided by 3 is 2x, and that's 54. And now we can combine the two x's. So 3x and 2x is 5x equals 54. And then this 5 is multiplying with the x. So we're going to divide by 5. And your x is 54 over 5. If it says integers or fractions, that's the answer. If it says it accepts decimals, you can go ahead and divide that. And if you use Desmos, 54 divided by 5 is 10.8. Okay. Next. All right, so what is the solution here? To 27 to the x minus 4 equals 3 to the 2x minus 6. Now, if you notice here, compared to the last problem, right, the big numbers are different. However, this is where you need to know that you can make 27 have a base of 3. So we need same base. So over here you can just use scratch trick, right? So we know 3 to the first is just 3. 3 to the second is 3 times 3, which is 9. 3 to the third is 3 times 3 times 3, which is 27. Ding, ding, ding. 27 is 3 to the third. So I'm going to rewrite this left side as the following. 3 to the third raised to the x minus 4. So this is 27, right? I just replaced 27 with 3 to the third. And that equals 3 to the 2x minus 6. Now, what you do here is you have a power raised to a power, you're going to multiply, right? So I'm going to put this in parentheses. So this would be 3. We're going to distribute that exponent. So that would be 3x minus 12. 3 times x, 3 times negative 4 equals 3 to the 2x minus 6. And now we have the same base. So if you have the same base, you move on to exponents, right? This is where we can drop the base and we can write just the exponents, and I'll do it right here. 3x minus 12 equals 2x minus 6. And now we're just simply solving this for x. Now I see an x and a number on the left, x and a number on the right, so there's no combining on the left or right only. But I'm going to move now this 2x to the left. It's a positive 2x. I'm going to subtract 2x on both sides. This will combine my x terms. 3x minus 2x is 1x. You don't need the 1 there, so it's just x. Bring down the minus 12 and bring down the minus 6. And now to get this x by itself, I have to get rid of the minus 12, so let's add 12 to both sides. X comes down, the 12s are gone. Use the calculator, your brain. Negative 6 plus 12 is positive 6. And that is the value of x here. Okay, the last one in this video, so let's get a little bit more complicated. All right. Oh, sorry. All right, so now we need to find out what the solution of this equation is. So 1 over 125 to the negative x over 2 is equal to 1 over 25 to the negative x over 3 minus 2. Goodness gracious, these are some complicated problems, but we'll try our best. So remember that we need, right? We need a common base. We need the same base. So I hope you know that these are related to 5, right? So over here, 5 to the first is 5, 5 to the second is 25, ding, ding, ding. And 5 to the third is 5 times 5 times 5, which is 125, ding, 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 right? So we know these two. But notice that these say 1 over and 1 over. Well, there is a rule with exponents. If you have 1 over x raised to the nth power, it's the same thing as x to the negative nth power. So what I'm going to do here is I'm going to take this equation and I'm going to replace 1 over 125 with 1 over 5 to the third. So 1 over 5 to the third to the negative x over 2 equals, and I'll replace 1 over 25 with 1 over 5 to the second to the negative x over 3 minus 2. And now I'm going to imply this rule right here, right? This would mean this is 5 to the negative third raised to the negative x over 2. And this would be 5 to the negative second raised to the negative x over 3 minus 2. And now I'm going to change my color because now we're going to multiply these exponents. So we're just going to straight multiply this. Now this is negative 3 over 1. So a negative times a negative is a positive first off. So this is 5 to the positive. 3 times x is 3x. 1 times 2 is 2. So there's the exponent over there. Over here, we're going to distribute the negative 2 to both the negative x over 3 and the negative 2. So this is 5 to the, so this is a negative 2 over 1. So negative times a negative is a positive. 2 times x is 2x. 1 times 3 is 3. Negative times a negative is a positive, and 2 times 2 is 4. Okay. And now, we have our same base, so we're going to focus on the exponent. So come over here. So we have step 2. We have the same base. So focus on the exponents. So this will be, we'll cross out the 5s, and this will be 3x over 2 equals 2x over 3 plus 4. Same thing here, least common denominator. Again, your denominators are 2 and 3. They can't become each other, so multiply 2 times 3, that's 6. Everything gets multiplied by 6. So 3 times 6 is 18x over 2. 2 times 6 is 12x over 3. And 4 times 6 is 24. 18 divided by 2 is 9x. 12 divided by 3 is 4x. Bring down the plus 24. This is an x term by itself. Over here is an x term and a number. Cannot combine the right-hand side, but we can move the 4x to the left to combine it with the 9x is a positive 4x. So let's subtract 4x. 9 minus 4 is 5x equals 24. And now this 5 is multiplying with the x, so divide by 5. If it wants a fraction, 24 over 5 is your answer. If it accepts decimals, you can divide those and also get 4.8. That was a lot. I get it. Okay, so we're going to do our best in class. Hopefully some of this made sense to you. And again, we'll just do our best in class. However, we do have a second video with a couple word problems. So pay attention to that video 2 coming up.